In this week, we shall be starting our discussion on a slightly different kind of topic which relates to hardware security. Now, when we talk about a product, when we talk about securing a product, there are actually two aspects to it. One is of course the software that goes into it and the conventional ways to secure things, to talk about security, to talk about breaking into a system. We actually implicitly talk about the software part of it, but also there is a hardware involved and there are some unconventional ways in which people can try and break into a system through the hardware backdoors. So, in these lectures we shall try to talk about a few things about that. So, the topic of our discussion is elements of hardware security. Okay. Now, in this lecture we shall be talking about some general attacks on hardware and some of the typical countermeasures that we talk about. Okay. Now, let us see what do we mean by hardware security in the generic sense. When you talk about hardware, well, most of the time when we talk about hardware, we actually refer to computer hardware, the computer system. Now, in a computer system, what are the things that are there? We talk about the processors, the CPUs, the different levels of software and of course, the memory systems. Broadly speaking, a computer hardware involves these three things. Firmware means some memory devices where some software are stored. So, it is a combination of hardware and software, you can say. Nowadays, we are seeing a great proliferation of mobile handheld devices. So, this mobile hardware is also coming in a big way in terms of their applications and applicability. Now, we all use SIM cards in our mobile phones and various kinds of device today. So, you have all seen how a SIM card looks like. A SIM card is a small microchip where a lot of information is stored. In addition to some sophisticated microchips where also some local processing can be done. There is something called radio frequency ID or RFID devices. These are the so called RFID tags. So, you can attach RFID tags to various kind of devices and you can monitor, you can locate those devices offline without any physical touch. In a wireless way, you can search for those devices. Then of course, we all use different kinds of Visa or Master card, ATM card. These are generically called smart cards. Now, in a smart card again, there is a small microchip you must have seen where there are some circuitry and also some computation capability. When you insert a card, some computations can also happen locally in this microchip. Well, and we shall see later, we shall talk about this later. There is something called physical unclonable function, in short PUF, which can be used to secure hardware products in a very flexible way. This is a new concept and people have been increasingly using this concept of PUF to have better security with respect to these hardware devices. Okay. So, moving on. Talking about the various attacks on hardware that are possible, let us try to make a categorization. Firstly, let us talk about physical attacks, where we are actually making some kind of intrusive attack on the device. What do you mean by intrusive attack? Let us say we are breaking the device, we are breaking open, we are removing the cover or the protective layer on top, something like that. We are making a physical kind of an intrusion in the device, physical attack. These are typically carried out on the actual device, like for example, if I have my SIM card and I want to see what is inside a SIM, I can break open my SIM, I can scratch some upper layer and so on and so forth. And these require some sophisticated hardware instruments and tools. Okay. These are not very easy to do, these require very sophisticated tools. Okay. There is another kind of an attack which, here we are all talking about hardware based attacks. These are called planned attack. Planned attack means, suppose I am deploying or I am marketing some devices. Let us say I am manufacturing TV sets, I am selling them in the market. Now, what I do deliberately, I am inserting some vulnerability in my TV sets, so that I can remotely do something which the customer who is buying the TV set is not aware of. For example, if the TV comes with a built-in camera, I can switch on the camera and see what is going on in the living room whenever I want to from a remote place, something like this. These are called planned attack, because this kind of vulnerabilities are put inside the manufactured hardware well in advance in a planned way. These are deliberately included in the hardware, right. And of course, there is another kind of an attack where you are trying to steal some data from some device where some data is stored. For example, in the SIM card, lots of contacts are stored. In my credit card number and other credentials may be stored, and so on. So, there are many hardware devices which can carry this kind of confidential data, and when you talk about stealing, it means how someone is taking out the data from this kind of devices. Like when you talk about SIM card, there is something called International Mobile Subscriber Identity, IMSI. This is a unique number. Someone can steal that from my mobile number, so that someone can try to clone it. Then for RFID tags also, there is something called unique identification code. Every RFID tag has a unique code associated with it. Someone can steal that. Someone can forge an RFID code with that same code, to duplicate it. And again, inside a smart card, there can be some secret key information and other confidential information like my CVV number, my card number, etc. All these things can be there. So, when I am saying stealing secret data, they involve trying to take out or steal these kind of data. So, here are some pictures. This is a pictorial depiction of a Trojan, something called Trojan which we will be talking about. This is a pictorial depiction of how we are securing a hardware. This is a very commonly used concept we shall be talking about. This is called reverse engineering, and this is some kind of a planned attack which we carry out on a device using some laboratory instrument, as you can see, like an oscilloscope, like some other probing devices and so on. These are something which we shall be talking about in some detail in the later lectures. Now, the types of attacks that can be mounted on a hardware device, depending on the complexity. First, we can talk about black box testing, where we do not know, or we do not know anything about the internal details of the circuit or of the device. We are not carrying out an invasive attack, we are not breaking it open. So, we have a device, we leave it as it is. What you can do, we can apply some input from outside and you can see what output it is generating. Just from the input output behavior, we can try to obtain some information about the device. This is black box attack or black box testing. The attacker sends an input to the circuit or device and gets the output. Depending on this input output behavior, the attacker can decide what is going on inside, what kind of algorithm is being run, and if it is a cryptographic operation, sometimes the attacker can also try and guess what is the secret key that is being used. This kind of an attack is a so called non-invasive type of an attack, because we are not disturbing the device, we are not breaking or damaging the device. These kind of attacks are called non-invasive attacks. Secondly comes physical probing, where I have a device with me and I am actually breaking it open in some way, so that I can probe inside and see what is happening. Maybe I have an IC chip, I am removing the top plastic cover of the IC chip and using a very powerful microscope or using some kind of a probe, I am seeing what is there inside the chip. This is called physical probing. Okay. Here the attacker plants some kind of a probe, it depends on the sophistication of the mechanism, what kind of probe you are talking about, into the chip itself and tries to read or retrieve some information that is present inside the chip. Okay. Since here you are breaking open the chip, you are making some kind of a damage in the physical packaging of the chip, this is a kind of an invasive attack, and obviously this requires very sophisticated instrumentation. If you try to break open a chip with a hammer, your entire chip will get destroyed. Okay, you cannot do anything. All right. Okay. Fine. Now, the third kind of an attack, which is very sophisticated, this is called reverse engineering. Now, for those of you who have some idea regarding how an IC chip is fabricated, you may be knowing that we start with a silicon base, that is called an wafer, and on a silicon wafer, layer by layer we put lot of depositions. There are various layers which are put, like diffusion, polysilicon, metals, contacts. So, it is like a building that is being constructed on top of that silicon wafer. And if someone using a very powerful microscope takes a picture of the chip from the top, the picture that we will be getting is only about the uppermost layer, because the other layers are hidden inside, right. Reverse engineering says you take a picture of from the top, you get the picture of the uppermost layer, how the layer is made, then using some kind of chemical you remove the top layer, then you take another picture, you get the picture of the next top layer, again remove it, again take a picture, you get the next layer. So, layer by layer you are exposing the chip, you are exposing the design. So, once you do this, someone can replicate the fabrication process and can clone a chip. So, you can steal the design of a chip and you can make a duplicate, you can fabricate it yourself if you want. This is called reverse engineering, and of course, removing the layers one by one and taking photograph and getting information is an extremely sophisticated process, and you need very sophisticated instrumentation for this reason, and you need very high resolution photography. Okay. Well, and a relatively new and very interesting technique, and of course, reverse engineering is obviously invasive, because you are destroying everything, okay, layer by layer. The last one we talk about is called side channel analysis. This is relatively new. Side channel analysis is also non-invasive, we are not damaging the device. What we are doing, we are saying that let the device operate, we are watching the device from outside and we are doing some measurement. We are measuring some sensitive parameters, we shall see later what these parameters are. These parameters can be temperature, it can be power consumption, current drawn from the power supply, electromagnetic radiation, and so on and so forth. We are trying to do some measurement, and variations in these measurements, trust me, will give you a lot of information about what is going on inside the chip. Particularly for cryptographic algorithms that are running inside a chip, you can very easily break the algorithm in many cases if the designer is not careful enough. Okay? This is what is meant by side channel attacks or side channel analysis. Some of the typical countermeasures that people have talked about or have come up with to prevent this kind of hardware based attacks, some of which I have just listed here. The first one says obfuscate data in registers and buses. Obfuscate means to hide them, to crypt them in some way. Suppose I am trying to store some data, I am not storing the data just like that, I am storing it in some kind of an encrypted form. So, that even if someone reads it, will not understand what is that. Okay? This is called obfuscation. We try to obfuscate the sensitive data that we are storing inside a chip. We do some kind of scrambling, encryption, stuff like that. Not only that, to prevent this reverse engineering we just now talked about, we can also obfuscate the IC layout. For person who will try to do this kind of reverse engineering, we are trying to confuse that person. We are using 3D stacking, that means instead of a single chip, we are putting chips one on top of the other, so that the problem of reverse engineering becomes more complicated. There are a lot more number of layers to go through. And secondly, we can introduce some dummy circuitry which can confuse the person who is trying to reverse engineer. As a designer, I am deliberately putting some dummy circuitry and I know how to activate it, how to deactivate it, but the person who is attacking may not be knowing that. Okay? That is how I can secure the device to some extent. The third one is interesting. We can put some kind of a metallic mesh on top of the IC, so that if some kind of a probe is tried to be put in, some kind of invasive attack is tried, there will be an immediate short circuit in that mesh, metallic mesh, and whenever there is a short circuit, all the stored data will automatically get deleted. That is how the chip is designed. So, the person who is trying to probe to get out some data, the entire purpose will get defeated. Okay? Similarly, there are some countermeasures which have been proposed against side channel attacks. Some of these we shall be talking about in some detail. Random noise generation, secret hiding, we shall talk about this later. And of course, physical unclonable function, we talked about this, just the name we mentioned, PUF. PUF is a concept, a device which can be used to design this kind of hardware security measures in a very robust and safe way. We shall see all these things later, how these are done. Well, there is another thing called hardware Trojan, which is also becoming important. Trojan, you know, from the ancient story of Greece, you know that Trojan horse, the story of the Trojan horse, the name came from there. Something is hiding inside something else. There is some kind of malicious logic, let us say, malicious logic that is inserted inside a circuit. Suppose I am designing a circuit which is supposed to perform some functions. I deliberately add some additional circuit, means I or someone else, may not be I, maybe some malicious entity is adding some extra circuit to my original circuitry. Well, without the knowledge of the designer or the user, let us say that as a user I do not know that this has happened, but someone has put some additional circuits inside my design. Now, when I am using my circuit, using my system, it may happen that there can be some triggering condition when this hardware Trojan can wake up, this hidden circuitry can wake up and some payload means some action which will be initiated, which will be a malicious action, maybe something will get deleted, something else will happen which is not intended. This is something which is the purpose of the so called hardware Trojans. Something is hiding inside the hardware, sometimes it can wake up and it can carry out some malicious activities. Because it is hiding inside the hardware without the knowledge of anybody, this is extremely difficult to detect. Of course, there are some attempts to detect it, but in general it is very difficult. Okay? This is how means an attacker can use Trojans to do something malicious. Well, these Trojans can also be used from the other side, from the ethical side also, like you can also use it for defensive purpose. Like when you are designing an IC chip, you want that someone should not steal your design. So, you deliberately insert a Trojan yourself whose behavior will only be known to you. So, someone else who is copying your design will also copying the Trojan along with that. So, whenever the Trojan wakes up, that person will not know what to do with that Trojan. Okay? So, it will be unusable, the circuit will become unusable. And also, as I said, this is used for copyright protection, sometimes it is called IC fingerprinting. Well, I suspect someone has copied my design, but I have no way to prove it. But if I have a Trojan that I have planted in my design, I can always find out whether that design which I am suspecting is a copy of mine also has that copy of Trojan there. If I find, then I can always say that well, it is a copy of my design. So, I can use some kind of copyright protection of my design using this kind of techniques. Okay. So, to summarize, the hardware implementation of some algorithm that goes inside a security device, this is of course based on some well known algorithm, typically some cryptographic algorithm. The point is, these algorithms are known to be very good, but the way they are implemented in hardware, that may not be very proper, that may have some vulnerabilities or weaknesses. So, this is the implementation that we are targeting. Implementation of the hardware may be faulty in some way, which results in vulnerabilities, and attackers try to attack vulnerabilities in various ways, just like software vulnerabilities. Whenever someone designs a software, there will always be some bugs. The attacker always tries to find out bugs and tries to exploit that. Okay. So, the next generation security chips that will come out, already people are working on it, they will include countermeasures to protect against as many of these kind of attacks as possible. This is the basic idea. Okay. So, in the next few lectures, we shall be going into some more details about the various kinds of hardware based attacks and some of the countermeasures. So, with this we come to the end of this lecture, where we have just given a bird's eye view, a very brief introduction to various kinds of hardware based attacks and some of the countermeasures people have talked about in this regard. Thank you.